welcome back to my channel. In this video, today we are going to build a Kubernetes heterogeneous cluster which consists of one control plane and two worker nodes. One of the worker nodes is going to run Ubuntu, while the other we are going to run as Windows, so that we can run mixed containers, mixed pods of Windows as well as Linux. Right, so I have prepared a document with all the steps that are involved. The version of Kubernetes we will be using is 1.33.1, and the memory and resource configuration I would say is 4 GB of memory, 4 CPU and 100 GB of disk. The control plane and the Linux worker node is running Ubuntu version 24.04. While the Windows node I'm using 2022 Data Center Edition. I already have installed the prerequisites such as container runtime, port forwarding. All these configurations are done, so we will not get into that. Let me clear the screen and quickly connect to the control plane terminal. My IP. Alright, I will make a quick adjustment to my container runtime config file. Okay. Sandbox image. Insert. I've noticed previously 3.8 is inconsistent, so it's better to use 3.10. That's what I've done. Now let me quickly restart the container service. Sudo system ctl restart container service. So that's been taken care of. Okay, let's switch to the root user account and run kube initialization to build our cluster. Alright, so while this is in progress, let's go through the documentation. So once we have our cluster built, we will proceed with building the pod networking. Now, previously we simply used the manifest file to set up the pod network. In this scenario, since we will be using a mixed mode, we will be making some adjustments such as changing the backend networking from IP/IP to VXLAN. The reason being, if we run the backend as IP/IP, which is not supported in Windows, while installing the Calico Windows component, we will encounter this error. To address this error, we will be switching our networking backend from IP/IP to VXLAN. So let's wait for it to complete. So that's for the networking part, and there is a sequence that we are going to follow while deploying the operator, the custom resource file, followed by the manifest. Now, on the Windows, we will have to make some changes such as creating a directory, creating an empty config file. We will take care of that once our cluster is built, and followed by installing the Windows roles and features such as the Windows container feature and Hyper-V role. So while this cluster initialization is in progress, let's take care of the Windows role and feature that is required for the container runtime to run on Windows. So let me switch to my Windows node, and we will open Server Manager. Okay, go to Server Selection, Server Roles. Let's select Hyper-V. Okay, now let's switch to feature, and on the feature we have to install Windows containers. Click next, next. For networking, I'm not selecting this. Next, let's go with the default. And because Hyper-V role requires a reboot, so I'm checking this box, so that will automate the reboot for us. Click install. Okay, so we have taken care of the Windows roles and features that are required to install the container runtime. So that will save us time. So we'll let it run. And let's switch back to our terminal. So that is still in progress. Okay, while this is in progress, let me show you the document. So there are two GitHub repository documentation on installing the container D runtime on Windows. This is one of them. So if you scroll down, go all the way to the section that says installing container D on Windows. So this is the script that we can use to install the container runtime, but it will not do a pre-check the Hyper-V role or the Windows container feature is installed or not. It will simply go ahead and install it. Okay. While there is another script which does a pre-check of the prerequisites. If not available, then it will take care of that. Now in our scenario, we will be using script 1. But if we want the script to do the role check or prerequisite check and do the needful for us, we can use this script. Okay. And one more thing, in the first script, here is a version variable which is 1.7.13. However, in our control plane, we are running container D version 1.7.24. So we will update this variable before we run this script to match the version of runtime on both control plane as well as the Windows node. Okay, let me check. Okay, that is restarting. So our roles and features are installed. That's a good thing. Our cluster is built. Let me exit out the root and run this so that our normal user have access to the cluster. And also, in addition, I'm going to run the auto completion so that we don't have to keep typing the entire command. Okay. And there you go. Right. Let's clear the screen, exit out of the session, and reopen. Right. And drag this guy up. Okay, let's do a test if our auto completion is working. And that is indeed working. So right, now since we have initialized our cluster, the control plane is still in not ready state. So now we will proceed with the networking. Okay, so first of all, on the networking, we are going to download the calico manifest file. And we will modify the backend networking. Right, I'm looking for this parameter. Okay, let's do a search in our file. There you go. Enter. So as you can see here, the default IP is set to enable. Go to insert mode and set it to never, and the IPVXLAN backend will set it to always. Okay, that's all we need to do in the manifest file. Let's save this changes. That's good. We are not yet ready to run the calico manifest file. Before that, we will run this manifest to deploy our Tigera operator. So that's installed. Now the custom resource. Let's download the custom resource, copy and paste. resource file is going to install, configure the calico networking, install the API server, which is needed, plus it will install Goldmain and Whisker. We're not going to cover Whisker observability as of now, but we can check if time permits. So this is what it is going to do. Let's run this resource file. We're not going to modify anything for now. Enter. But if we want, we can skip Goldmain and Whisker. Okay, so that is done. Now the next step is we will run the kubectl apply command and invoke the calico manifest file. Alright, okay, now let's do a quick check with the command get nodes. Before that, I'll clear the screen for a better view. Ready, and that is ready. Control plane node looks good. Let's run this once command to check the status of calico system parts, if any been created. Not yet. We can do an overall check for all the pods and all the namespaces. So as we can see here, it is in the process of creating. Core DNS is running, so that's good. Right, so we have all the calico components getting installed now, the system pods. Now if we run this watch command, we should see the status, okay? We will wait for it to finish. Once this is done, our control plane node would be ready, and then we can switch to the Windows node. Okay. Almost there, just 2 of the components are remaining. It should finish in time. Perfect. So all our calico components, system parts are running. Let's do a Control C and do an overall check. Come on, kubectl get pods, right? Okay, so at this point, our control plane is ready with the networking configured, and now we can completely focus on building our Windows node. So let's switch. Okay, so the installation of the feature and role, which is Hyper-V and Containerd, is in still in progress. Oh no, that is completed already, as you can see. Let's close this wizard and we'll open PowerShell and try to proceed with the steps. Okay, so now the next step for Windows machine or Windows worker node, first we have to create an empty directory called K. So let's do that. mkdir c k. It's done. The next step is we will be creating an empty file name config. So we will use new item command. All right. The next step is on the control plane. We will open the kubeconfig file, which is by running the cat command .kubeconfig, and we will copy this information and paste it to the empty config file on the Windows machine. Sorry. Let's go back again. Select all. Copy. .exe. Okay, that's open. Let's paste it and close, save. That has been taken care of. What next? Right. Next, we have to install the container runtime. So I'll go back to our instruction document and copy the script block to install the Windows container runtime. Open PowerShell IC maybe. Okay. Scroll up, and like I said, we will update the version to 2.4 and enter or execute the play button. So that will prepare the container runtime. And we can also check the version on our control plane by running this command. Double check 1.7.24. So that is good. Now once that is installed, we will have to proceed to the next step, which is download the script file for Calico Windows. Let me copy this command. Right, container runtime is installed. We can also run the same command on the Windows machine and check the version. So that it looks good. Let's get out of PowerShell IC and we'll open PowerShell again. So this is going to download the install Calico Windows PowerShell script. Let's hit enter. And the next step would be to run the script with the two parameters, which is download only yes and cube version 1.33.1. Since I mentioned in the beginning we are using cube version 1.33.1, so we know the version we are using. In case we want to validate, we can run again same command cube get knows. So that tells us what version we are running. Okay, that is downloaded. Let's go to the directory. C drive. There you go. We have the script. Let's pull the script to our PowerShell. Space and parameter. Let's hit enter. While this is running, let's switch to our documentation. Right, now once we have our PowerShell script run, we have to set environmental variable for the container D CNI bin and conf file folder. So if I go to File Explorer and go to Program Files, container D, there is a CNI folder, but the bin folder is missing. So what we are going to do is create an empty bin folder in here. Right. Let's minimize it. So while this is installing, this might take a few minutes here. I haven't gone through the entire script here, but I assume this script will take care of installation of the Kubernetes components such as kubeadm and kubelet on the Windows machine. There you go. As you can see here, it's extracting the star file to CK. Right. Okay, that is completed. Now the script, you can see the backend networking is VXLAN. It's because we modified while deploying our pod network. Right, so it has auto detected, so that's a good sign. Okay, let's move on to the next step. That is, we will set this to environmental variable. And there you go. That's our first variable. Let's copy over the second variable. Right? So our two variables for the bin and conf directory are set. Now the next step is we have to go to this directory, which is automatically downloaded when we run the first script, and there is install calico. Here's a script, so we will run this script. There is no need to pass any variable or parameter. Simply execute. So this will install the components that are needed, such as the calico agent service and calico monitor, I guess. So if we open services, we will see two services. So calico Windows agent and startup, right? Now there is a second step, that is a start calico. We're going to run this script. Again, no parameters needed. Okay, calico initialization has finished and both the services are running. We can do a refresh and check. Yeah, that's a good sign, looks good. Let me quickly open the switch, and yeah, it did create a switch, which I saw while the script execution was in progress. This is external. Okay, we don't need a Hyper-V manager anyways. Right, the next step after running the install calico followed by start calico, we will further go to the subfolder inside calico Windows directory, which is Kubernetes, and we will run this script which will install the kubeproxy service for us. So let's pull this script to our shell and run it. Okay, once that is done, if you go back to the services and do a refresh and look for kubelet and kubeproxy, you will see these two services. They're not running. Let's run it. From here we can run it, or we can also run it from the command prompt by using start service proxy. That's good. Both our services are running. Now at this point, let's go back to our control plane and run get pods. So you can see here our Windows node is now added to the cluster and it's in ready state. So we can do a describe to check details of that. Let me pull this. Yeah, this is good. It's node ready state, and kubelet is posting ready state. So that looks good. Let's clear the screen. Okay, now it's time to test our deployment. Before that, I'm going to run this affinity update, so which will allow us to run the Windows pod. That is done. Okay, so let me open up this article and open the sample YAML file to deploy our Windows pod. Let me copy, go back to a control plane, clear the screen. Now let's name it win.yaml. Key in the password for the root and paste in the content. Let me try this guy up. Okay. Now there are a few changes that we will be making in this YAML file. One is the image repository, which says ITSC2019. I've seen that image pull-off error occurs. Probably the image is no longer available. So from 2019 we will switch it to 2022. And the second update we are going to make is the number of replicas. I will scale it down to 1 since it is just a test deployment to check our heterogeneous cluster. So let me save this file. Okay, Control X, and yes, it's done. Now we will run the command apply to deploy our Windows pod. That is done. We can run the overall command kubectl get pods of an A, and we can see it is creating the Windows container. At the same time, we can switch back to our Windows node, and on the PowerShell we can change the directory to K, and we can make use of the kubectl in here as well. If I do get pods space -a, I get the same list. If I do kubectl describe pod, and I copy the pod name, that will give me the details of the pod. So we can see right now the status is pulling. So it will take some time. We will wait for it to complete. In the meantime, let's power on the Ubuntu node. Okay, there it is already. I will go ahead and connect to that node, clear the screen, and I know the IP. Let's SSH it into the node. We will switch to root account. Let me look up for the join. Clear the air. KVDM token. Great. I'll print it out. Okay, that's the join command for our nodes. Let's copy it and switch to our worker Linux node and paste it in. Alright, that's ready. Now if we run the command get kubectl get nodes, we will have 3 nodes. One is the control plane, which is running Ubuntu, unode 1, which is a Linux node, again running the same version of Ubuntu, and a W node, which is a Windows node running 2022. So we are right now in the process of testing a Windows container pod creation. So that is still in progress, which will take some time. We'll let it run. In the meantime, we'll try to test creation of a pod on the Linux node. So let me first generate a manifest file for Nginx server maybe. Create deployment, I'll name it Nginx, and I'll use the same Nginx image, and I'll go for a dry run. And let's output it to YAML. Okay, we have it. Let's open the manifest file for our Nginx deployment in Vim editor. And now, since we have a mixed cluster, I have to tell the cluster on which node, which part to be created, right? So that is done using the node selector. As you can see, if you refer to this Windows script, there is this section which talks about node selector. So I'm going to copy this part instead of writing it down and put it in our insert mode, hit enter, paste it in. Let me correct the indentation. It's good. Save the file. Sorry. Okay, that is good. Now we can run the kubectl apply command. Nope. Did you pay attention? I copied it, but I did not modify. So we want to run the Nginx on Linux, not on Windows. Right? Control. Let's save this file. Okay, now we are good to go. Now I have to add Nginx. That's created. Now, let me clear the screen first. kubectl get pods A. I'll use the white command. The Windows container is created on wnode2, which is my Windows node. Now, since we have selected the node for Nginx, it is running on the Linux node. Let's also check if we can expose and access the Nginx. Expose deployment Nginx. We're going to do no port. That is good. Let's clear the screen again. Service. Alright, so the port is this one, external accessibility. Let's run it. I know the IP of my control plane. So there you go. Perfect. So our Linux based pod Nginx is running. Now it's time for us to wait for this Windows container to be ready and do the final testing. So let's do this and check. Okay, that is still in progress. It's gonna take a while. Let me see. So 40 MB, that's still not close. I think it will occupy close to 2 gigs of system space. Let me see here. Container D, root. 2.4. Okay, so that's downloaded complete. Should not take much time now. I haven't checked this before, but let's try. If there is interconnectivity between the pods. Yeah, perfect. So, as you can see here, the pod that was created on our Linux node is accessible from our Windows node. So, we can confirm the inter-pod connectivity in the cluster is good. So, if we have to build an application stack that consists of Linux as well as Windows, that is going to work. That deployment is definitely going to work. Perfect. As you can see here, our Windows pod is now ready. Let's terminate. We will check now. Get service. Okay, the Port number is this one, so let me see. Accessibility, remove. There you go. Windows pod that is deployed on the Windows node in a mixed Kubernetes cluster is working. Now let's also validate the same from our Linux node. We'll do vice versa. A pod created on a Linux node is accessible on the Windows, so we need to check the other way around. Okay, let me cancel this guy and (72, 16, 130, 67). There you go. So our paths that are created on different nodes can talk to each other. Feel free to write your comments in case I have made any mistake here. Thank you for viewing. Please do subscribe if you like the content. Thank you.